Alright, so we're going to talk about transverse versus longitudinal waves. In this video, you will be able to distinguish between transverse and longitudinal waves, identify the two different types of waves visually, and define the terms mechanical versus electromagnetic waves. So first, we need to define what a wave is. And in your real life, you have probably seen numerous examples of waves. And for example, the waves that you see in the ocean, and even the American flag, which is waving up and down because of the wind, right? So disturbance or a variation that travels through a medium is defined as a wave. So there is some kind of variation that is present in both of these scenarios, which is enabling them to have the properties of wave within them. So waves can be broken down into two major parts: mechanical waves and electromagnetic waves. Now let's focus on mechanical waves. So mechanical waves are waves that require a medium to transport energy from one location to another. So without a medium, you won't really have any mechanical waves. So what are some examples? Sound wave, the waves that you see in the ocean, and rope waves. So for example, without water being present, you won't be having any ocean waves, because in order to have ocean waves, you need a medium present to transport that energy from one part to the other. Next, we have electromagnetic waves, which are waves that are capable of transmitting energy through a vacuum. So they don't really need a medium to travel that energy through, and these waves are produced by vibration of charged particles. So can you think of some examples? Well, we can think about space, right? We have the sun, which is emitting this huge amount of energy, and that energy, which is in the form of light, travels to the earth, and the way it travels through is vacuum, right? In space, it's total vacuum, but still those particles are able to reach the earth. And the reason that they reach the earth is because that they are electromagnetic waves, which do have the ability to travel without a medium. They are able to travel in a vacuum. So an example of electromagnetic wave is going to be the light waves. Also, right bejiv, you have rainbow, right? You have the sun here, the sunlight passes through the slit, it then passes through the prism, and then you see the rainbow form. And that is because of this. So in this lesson, we're going to focus on mechanical waves, because they can be broken down into transverse waves and longitudinal waves. So what are these two different types? Well, let's start with longitudinal waves. In longitudinal waves, the oscillation is parallel to the direction of the wave. So what's happening here is that you have particles which are not necessarily moving down the tube, but which are oscillating back and forth. Now, don't confuse this with transverse waves, because transverse waves actually form these humps, which you might be familiar with, but longitudinal waves are going to be defined as straight lines. As example, you can see is spring. When you compress a spring, it is an excellent example of longitudinal wave, because you are having that those particles within the spring are oscillating back and forth. Another example is going to be the sound waves. On the other hand, transverse waves are waves in which oscillation is perpendicular to the direction of the wave. So here you are going to have the humps present. The wave is going to go up, then it's going to come back all the way down. It's going to come up again and go all the way down. So oscillation is perpendicular to the direction of the wave. Example, the rope waves are excellent examples of transverse waves. And I hope that this video helps you study for AP Physics.